Okay, in the previous video, we talked about weathering and erosion and deposition, and we talked about the importance of surface area and how it's related to the rate of weathering. So in this video, I want to explain surface area further, and we're going to use the same box that I showed last time, and I've already written some measurements. Just to have full disclosure here, I simply made these numbers up. I don't have a ruler with me, but anyway, they're approximated. So here we have the first surface of this box. Okay, so we need to find the area of each one. Well, most of you already know that the formula for area is simply length times width. That's actually very easy. Now, again, as I said in the last video, I always wondered, wait, is this a length? Is this a width? Well, for our purposes here, it's not going to really matter. As long as you have two of the dimensions, you can multiply them together and find the area, as long as it's a normal geometric shape, polygon of sorts, and you've broken it up into either rectangles or squares, that's going to work. So here we have a rectangle. So easy enough, and we've got two sides here. So to find area, we simply have to multiply them. So 30 times 10 is pretty easy. 30 times 10 is simply 300. Now, when we're finding area, though, we have to, and anytime we're doing science, we have to be careful about the units. So 300, but we did centimeters times centimeters as well, so we have to multiply the units. And in the same way, x times x would be x squared. Centimeters times centimeters would be centimeters squared. And I want to note that this is a difference, obviously, between volume. So some students get mixed up between surface area and volume. With volume, you would use cubic centimeters, but here we're not going to use cubic centimeters at all. We're simply going to stick with square centimeters, because we're only going to be finding the area of one side at a time. So going on to the next side here, we have 30 times 8. So if you need a calculator for that, that's fine. You can use a calculator in science classes, but 30 times 8 would simply be 240. And again, we also have to multiply centimeter times centimeter. So that would be centimeter squared. And we've got this side as well. So this gets kind of tedious. You can see, okay, this is a lot of boring multiplication, but we're going to make it a little bit easier in a moment. So here we've got 10 times 8. So 10 times 8 is simply 80. And again, we have centimeters times centimeters, which is, of course, centimeters squared. Now, we did this with 3 sides. Clearly, this has 6 sides. But there's kind of a cheat, because if this is 300 centimeters, the opposite side is also going to have 300 centimeters. 300 square centimeters. So I'm just going to go ahead and write that here. That's 300 square centimeters. Same thing here. The opposite sides are going to be the same. So if this is 80 square centimeters, this side, where my paper fell off, is also 80 square centimeters. And we've got one more pair of sides. We've got the 240 square centimeter side, and the opposite side is here, which would also be 240 square centimeters. So at this point, I've got the area for every single side. The only thing left to do is to add them all together. Now, in order to make this easier, I'm going to use this calculator that can also use parentheses, because that's going to minimize my mistakes. So we want to be as accurate as possible. So what I'm going to do is start my parentheses, put one of the values for the side. I'm going to start with my 300, put inside that parentheses 300 times 2, close parentheses. That's going to account for both this side and the one opposite. Then I'm going to add those with again, I'm going to start my parentheses and do 240 times 2, since there are 2 of those sides, close parentheses, and then add my final side, the 80 and then times 2, which is going to give me a total of 1,000, you can see that, 1,240 square centimeters would be my surface area for this box. Now, just to compare what would happen if I cut it, let me see if we can cut through this. I really would like a surface other than my computer to cut over, but if you can imagine me, which you should be able to, cutting through this box completely, which apparently, I don't know if I'm going to be able to, but I'm creating snow, which relates to ice weathering and surface area, I suppose. But if I were to cut all the way through this, and then cut again here, I would be essentially creating more surface area out of this box. So now there would be a new surface, there's more surface exposed. And I think that it's very logical if I were to pour water over this now, or expose it to some other sort of weathering, it would weather much faster than when the box is intact. And that's because now my box has much more than the 1,240 square centimeters of surface area. So that's my video, or group, pair of videos on surface area, on weathering, erosion, and deposition. I hope this was helpful.